So many of you already know that Makers Academy is a 12-week coding bootcamp. It's an intensive learning experience, and over the course of their time here, many developers go from just knowing some coding basics to being able to build a web application from scratch. Just a few months ago, the developers you're going to see tonight were enjoying their first week getting to grips with task-driven development and Ruby classes. Now they can build and deploy entire projects to create the products that they'd like to use. Our next available cohort is starting pre-course on Tuesday, the 14th of April, which means starting the bootcamp on the 11th of May. So now on to the presentations. I'm really proud of December. They've had some really great ideas for their projects, and I'm proud of how far they've come in just these 2 weeks. All of them have stretched themselves and have learned something new. So our first team tonight is called the Visual Project. Please give a warm welcome to our first team.
Everyone ready?
Yeah.
Let's do this. 3, 2, 1, go. Hey guys, we are the Visual Project. This is me, Tom. This is Lucian. This is Vish, hence the name. And this is Alicia. We decided to create a JavaScript and Node.js based visualizer for Spotify because they don't have one. We wanted to build something that we could show off to our friends and family. We wanted to do something that we could just frankly show off to anyone. So I'm going to let everyone take it away and let Vish show it off, but I want you to know that we worked really hard on this and I really hope you enjoy it, okay?
Okay, so we start off on the front end of the app where we are required to log in. It will eventually log in. Play the video.
There we go.
And then that takes us to the back-end server of our app, which looks after the authentication. And then we are rerouted back to the front end where we are given a no playback detected message where we now need to confirm. I'll just let you enjoy the visualizer a little bit. So basically the spot size is dependent on the energy. The color is dependent on the key, and the speed is dependent on the BPM. We decided to create 2 visual components. We have a literal visual component and then an actual component here, which basically shows every bit of data that we've extracted from the Spotify API. And when you scroll over those buttons, it basically shows you the exact raw data that Spotify has given us. And also the mouse is interactive. As you can see, it's making that ball larger, which is pretty cool. And yeah, that's pretty much it. That's our app. So that's how our application runs, well, what it does. And now to explain how it works, Lucian.
So the first slide here is actually showing the workflow of our server. But this is a little dry, so we actually have another picture here which represents the same information in a slightly more pleasant way. What has been really impressive though with this project is that each member of the team has actually worked on each part of the project and understands how it all works and how it fits together. We built this program on 2 different frameworks, a server for the back end and a website for the front end. The website on the front end utilizes React.js, which was a really important part of the program, because it allows us to re-render the visualizer every 15 milliseconds without affecting the rendering of the whole page. Another part of that was using the Spotify API, which is rich with data. So little things like danceability, tempo, which you saw in the previous slide, or the slide before. And we use that information to dynamically change the visualizer from song to song. So danceability was representing the circle size, and these will obviously be changing as the songs change. One of the other things that's been really nice about this project is that we've been using API calls very heavily and an end-to-end architecture. And to talk about how the process went, Alicia.
Yeah, so we knew early on that we wanted to do a music project, and we were going to be working with the Spotify API. Just deciding what to do was a bit complicated, so we spent a whole day planning on the first Monday, and decided that the visualizer what we were gonna actually do. So to begin with, we managed to connect with Spotify, but this is all we had, just showing the raw data. And then we managed to figure out like a rough idea of how the visualizer would be, but connecting them was a bit more complicated. So each day we ran a daily stand-up and retro, which you can see here, Tuesday to Wednesday, like Tom ran it, and we swapped each day who was going to be running the retro, which was really good to get different perspectives. We've got some just examples of like our process, drawing out the visualizer, and also in stand-ups, like focusing on wins of the day or of the day before, and just like trying to boost morale each day. So some of the challenges we faced were actually learning React. None of us, we'd only done 2 weeks of JavaScript before, and React is written in JavaScript, so that was a big learning curve. We probably should have spent a few more days at the beginning just actually getting familiar with it instead of diving right in. Because on the first Wednesday, when we were meant to have our minimum viable product, we still had just the blank page with words on it, nothing too exciting. And that was actually really stressful, but we like all worked together on it. We took a night off and just came back in the next day, and just having fresh minds really helped. We got through, and as you can see, yeah, we got something. We relied on Trello actually to communicate, just sharing learning documents, which there was a lot. But yeah. Anyway, thank you for being here, and if you want to check out our actual products, you can head to our GitHub. It's here.
Cool, thank you. So our second team is Finbot. Please give a warm welcome to Finbot.
Coaches, fellow makers, esteemed guests from across the pond, we have an exciting new product launch for you today. But first, what is that abstract thing that for some is in such gross oversupply and for others just a little bit out of reach? That one thing that separates society when we don't want it to. Part of the reason why we're all here as makers. It's money. Our Nikki came up with a fantastic idea to help increase financial literacy for anyone in an easy to digest way. So what we're bringing you today, you've seen Siri, Alexa, Google, and now UB. UB is your AI financial robo-educator. He uses machine learning to answer your questions and help point you in the right direction to further educate you on how to amass your own empire and build your own wealth. I'm going to let Emily show you how it works.
Okay, so when you load the Finbot app, you'll be first greeted by UB, the personal finance assistant, and it will suggest, you could type in, sorry, is this what? I'm not sure if it's running. I'm not sure. Space, yeah, sorry. Okay, yeah, so it'll suggest typing help, and then UB will generate different financial topics, as you can see here. You can type in a specific term like student loans, or you could also type in something like this, like I'm a student in debt, and it will come up with a definition or a snippet of information, a couple of related keywords. And if you type in yes, you'll be shown 3 different links for each different topic, and as you can see, it goes to the correct link. it has been trained not just to respond to specific keywords, but also to like different questions and patterns. So you could type in mortgage, or you could also type in like homeowner's loan, or like I want to buy a house, and Alp will recognize it. Yeah, and also if you type in something that's like not recognized by Alp or an incorrect spelling, it will tell you that it doesn't understand. And then also we have this nice feature here, which draws in the latest financial news stories from using an API. Okay, so now I'm going to hand over to Megan.
Right, I bet you guys are all wondering how we built this amazing product. I'm going to show you. Wix, an all-in-one platform to build websites. Yeah, I'm just kidding. No. This is our actual tech stack. There's a lot going on here, so I'm just going to talk about a few things. So before we started, we knew that we wanted to focus on natural language processing, which is a branch of artificial intelligence that focuses on human language. There's already been a lot of work done in this field, so to build on top of it, we focus on NLTK and TensorFlow. NLTK is Natural Language Toolkit, and TensorFlow is used to build machine learning applications. Those are both built in Python, so naturally we used Python for our backend. For our front end, we went with React, which is a JavaScript framework. And then to link them all together, we built an API using Django. And then we deployed using Heroku and did some tests in those other two. So other than JavaScript, we had not used any of these technologies before last Monday. So to talk about the difficulties that go along with learning all of that and linking them all together, I'm going to hand it off to Nikki.
So I'm really proud of this project, but let's talk about the challenges that we faced. So of course, like Megan said, there were a lot of new technologies, and not only it's hard to learn them, to test them, to deploy them, because we have two servers that are deployed and they send requests to each other. So that was another difficulty. And of course, at Makers, we've been trained in web development, not data science and machine learning. So the first 2 days, we had to do an intense crash course on this topic, and then also we had to install and uninstall different versions of some software like TensorFlow a few times. I think I had to basically make sure that everyone had the right version of TensorFlow, which is like at the core of the machine learning part, because some versions had security vulnerabilities. If you basically are an open source project and you let other random people give you data, it could be malicious data. So we had to kind of make that trade-off. And overall, we came through and we have this amazing product. So to talk more about our teamwork, Shadi.
Hello, everyone. As my lovely team just mentioned, and as you've seen, we ended up using a lot of new technology and languages that we didn't know anything about. So we knew in order to achieve our goal and do this in such a short amount of time, the key was to be very organized. And we achieved this by having daily stand-ups, making sure that we prioritize the tasks that we need to do that day. Oh, yeah. So, yes, prioritizing the task and making sure that we set realistic goals, for that day. At the end of the day, we would have a retro and we would celebrate our, little wins. Even though if there were no wins that day, just having a nice lunch was, a good win, if it wasn't Tesco. You all know. Sorry, off topic. And also having retros, in the evening, as I said. I was lucky to work with a great team. Everyone was very dedicated. We even ended up going to Basil's house on a Sunday, to actually work. And that just shows that everyone was very eager to, have a great product, which we are very proud of, and I think we have achieved that. One other thing that was helpful was sharing of information on Slack. We made sure that everybody was up to date, so if anybody came across any new technology or any, an article or anything useful, we shared it with everyone. So we could all be on the same track. And yeah, so very proud of our product, and thank you very much for listening.
Our next team is helping us all be a bit more environmentally friendly. Please give a warm welcome to Seasonal Regional.
Hello, we are Seasonal Regional. We were looking to make an app that would highlight to users the impact of carbon emissions based on food choices that they make, because there is a huge range of difference between foods, and I don't think everyone realizes that.
So we were given the theme of lifestyle for our app, and we thought we're 6 different people with very different interests in life. The one thing that really unites us is we're all terrified of climate change, right? As most of you probably are as well. So we spitballed with a few different ideas, including a pollution tracking app and a seasonal gardening app, before we came to the conclusion that the easiest way for most people to reduce their carbon footprint is by eating seasonally and locally, and so we have built an app to help you do just that.
Throughout the project, we used an effective pair programming process. On the first day of the project, we had a team lunch where we talked about what we would like to achieve during this project, and we also ate some food. We started each day with a stand-up where we would discuss our goals for the day and which teams would work on what. We ended the day with a retrospective where we discussed what went well, what didn't go well, and how we could improve on those things.
Right, so I'll talk to you about the bad stuff, the challenges. So basically, from the very beginning, we had to decide what technology we wanted to use, and we decided to go with Vue.js, Firebase, all things that we had never seen before. So we had to learn how to use them within the time limit that we had. And well, for those who have to do your next projects in the coming months, I would suggest to just look up on YouTube and online tutorials. There are some of them that are very good. They were good for us, good enough to do this stuff. And well, what else do I want to talk to you about? About the data. There's a lot of data that goes into this, and we did not know where to get it from because most people want to be paid to give us that data. So we had to deal with free APIs that are a little bit more, well, bare bones, but we had to make the most out of what we could achieve for free because our financial budget was zero. So, and also, well, we had some blockages. As you do sometimes, some people who are already here, they usually get stuck. That's how we say it usually. That means that you cannot solve a problem very quickly. So we had to come together as a team, and this way we could be more efficient. We could resolve blockages more often and have more breakthroughs. And also, I'm going to talk to you about the sicknesses that we had, because a lot of the days we were not the full team because some people were sick, so we had to work around it. But I think all in all, it wasn't so bad. I think there's a lot of good stuff that came out of it, and he's going to talk to us about it.
Thank you.
There you go.
We're going to speak about the things that went well, and it's a great pleasure that we stuck to a 2-week deadline, and we delivered our features on time, at the same time abiding to the minimum viable product principles. The second thing is that we quickly familiarized ourselves with the technologies Marcello mentioned. The critical point was that we kept exchanging ideas with each other on a daily basis, and this made the whole difference in the overall teamwork efficiency. And in the end, we are happy to have a blog in which we share our daily progress and you can check our documentation as well. Now Ben is gonna walk through the actual app.
Okay, so what does it do? Right, does that play? Yeah, here we go. Right, so this is local and seasonal ingredients. Defaults to the current date. We can select other dates. We can show all the ingredients. So click on an ingredient, beef. Beef is unsurprisingly really bad. So we'll click on the ingredient eventually. And this brings up a list of recipes. It's only 10 at the moment. So then we go to the actual ingredients. We have all of the ingredients broken down by carbon footprint. And from here, and for the weight of the ingredients, we color code whether it's good, bad, or indifferent. Clearly it's red because it's bad because it's beef. We can click into the original recipe. That shows us how to cook it. But it's not all bad news. Let's pick something that's a bit better than beef. My favorite ingredient. Beer. Who knew beer was good for the planet? So we can select beer recipes, and on that note, I think we should probably have a beer. But wait, there's more. Where do you get your beer from? So here are a list of local farmers markets. Beer is not the only produce available, but local farmers markets to tell you where you can get local produce from to be better for the planet. That's it. Thank you.
Please give a warm welcome to our next team, Net Positive.
Hi, we are Net Positive. We are a group of Pong enthusiasts which wanted to develop some AIs which would play Pong. So we wanted to make a user interaction where you could interact with either a neural network or some sort of procedural-based AI to develop a kind of player challenge. Our most powerful AI is one which is developed by Andrej Karpathy of OpenAI. And we used his architecture as a basis to kind of like abstract and grow off. So we have our own neural network in the model. So a neural network is just a mathematical model which is based off of the brain. And it looks at a set of pixels, much like this, and it feeds through all these kind of abstract layers, and what comes out is utter trash. And but that's okay, because we punish it for making utter trash, and then when it makes things which are less trash, then it improves our model, and we get a functioning network which can play a game.
Okay, so how did we implement our app? So we actually built the actual game itself in JavaScript in the front end. We connected that to a Python backend, which contained a series of bots. And then so these bots would tell the front end in which direction to move the paddle at any given time. We then train these bots in a separate cloud environment until they got really good on a different version of the game. It's quite similar, but a different version. They got really good, then we kind of ported them back into our backend, so our Python backend, and then they played our game, essentially. And the end result was this. So our game has 3 different modes: arcade mode, in which you can play against different AI bots, multiplayer where you can play against different human players, and training where you can actually see the bot train as well. So here's arcade mode. So the bot on the right is the one that's being trained. Training where you can see the bot actually train and get better over time. And then multiplayer where you can challenge your friend and play a human. Okay, and we're now going to look at the bots in a little bit more detail.
Okay, so we have 5 different bots in our game. So we have, and they're all based off tennis player names with AI kind of puns. So we have RL Federer, Steffi Graf, Novak Djokovic, Bjorn Cyborg, and Andrea Agassi. They're all different types of AI. So 2 of them are neural networks. So RL Federer, which is the best bot in our game, is OpenIA's network. Bjorn Cyborg didn't train as well, but that is our own net. So we did build that ourselves. And then the others are just more procedural bots built in Python logic, which we started with Steffi Graf, and she basically just follows the ball on the page.
So just to elaborate on what Asia's saying, this is a really nice graphical representation of a little bit of the data that we've kind of yielded from it. So Dr. Andrej's bot that we can see is the orange one here. So we can actually see it's pretty much the gold standard in terms of what we've made. In just a few game numbers, we can see that its performance is actually far superior to ours. That's not to say that it's a complete failure. So this one here, the blue one, is Beyond Cyborg. We're very proud of. What we did really, we tried to think, let's look at all the parameters, look at all the layers in the net and everything, and try and increase that. But actually, less is more. In the context of this game, we actually found that just a really simple neural network, if there is such a thing as a simple neural network, a very simple layer, actually performed a lot better. This one actually had over 1 million tunable parameters, so quite a lot going on. And again, we even tried with 3 different cost functions and even 5, but we found that actually simple is best. And Dr. Andrej clearly knew what he was doing. But we're very proud of Bjorn anyway. Let's see what's going.
Yeah, so I'm going to talk about the challenges we faced while doing this project. One of them which was the communication of data. So we needed a way to get our robot to communicate what moves it wanted to make to the host. The original way we tried to do this was with a method called post requests. That was too slow for us, so we swapped over to using WebSockets. The other issue we faced was that in training the AI, we used a program called AI Gem. The bot got really good at AI Gem, but then when we plugged it into our version of the website, it didn't understand the change in size, essentially. So we had to make our environment look more like AI Gem to pass that. The way we solved a lot of the issues we came up against, training each other. Nick hosted a lecture on the very first day, which was great. And with all the research I did, I bounced off the rest of the team to see exactly what we could do, what would work in the project, what wouldn't. Other than that, we had very good commits all the way through the project just to make sure that everyone understood through every iteration exactly what was happening so they could just read the commits and catch up that way. Outside of that, everyone just kept a really good workflow.
So in conclusion, first of all, huge shout out to the team. I mean, there was a lot of uncertainties going into this and could it even be done, but fundamentally we genuinely built a net and it genuinely plays Pong and it sometimes wins, which is pretty good. We created the game with the AI, so actually our game now that we built in JavaScript can actually train the bot and the net itself. It is a little bit slower than the kind of outsourcing that Tom was talking about, but it can be done. So with more time, it can definitely get better and more adjusted to our game as opposed to just bringing in the transfer of what it's learned from the other game. And lastly, I mean, Nick's, Tom, everyone, Asia, Jake, great passion. Nick's been like an infinite source of machine learning. We learned a bunch of new tech that, it's been the theme of this course really, but it's just been wonderful. It's a pleasure to work with everyone. And we're really happy with the product, so yeah, thanks.
Team of the evening, please give a warm welcome to the Technodactyl studio.
Human beings have been around for roughly 200,000 years, according to the earliest fossil records we know of. Consider that dinosaurs roamed the earth for 160 million years. To put that into context, Tyrannosaurus rex is closer to us now than it was to the Stegosaurus, which is pretty crazy. To honor these majestic animals, Technodactyl Studios would like to introduce their debut game, Dino Run. It's a side-scrolling platform game where the level is automatically generated based on an audio file that the user uploads.
Thank you. Yes, and it was built. Yes, it was built with this fantastic team of 5, using best practice at makers of pair programming, which essentially is a process where you partner up with an individual. In our case, it could be a team of 2 and a team of 3, and you switch partners in terms of driving the code or being the person who kind of does the research behind the scenes, and you switch. It worked quite well, worked quite dynamically. The extra person could liaise between the 2 different groups as well quite well. But beyond that as well, it was just a nice group. We had lunches out, cooked dinners in, and in between each days as well, we of course had the retros and stand-ups to make sure we were all on the same page and continuing learning as well. So that all worked really well. But there's a photo of us having dinner.
Cool. So, in Makers, we're taught to design code by test-driven development. That's the case of writing small tests and letting those tests define what code you write. Problem is, none of us are game developers or music analysts. So, for the first week, we basically were just throwing down code, not really knowing what we were doing, and eventually got a product out which we could look back on. So we figured out the 2 main parts of what we needed were effectively a music analyzer and a game engine.
So, as Chris said, we have no idea what an audio file was. We tried to look for some libraries that were able to solve this problem for us, but nothing was really fit for the purpose. So basically we went back to school. We spent 24 hours learning how audio wave is composed, what the frequency, the pitch, the amplitude are, and nothing of this was actually code related. When finally everything was a little bit clearer, obviously you can see from our work, we still had our main problem. How do you extract this information from a file? And as you can see, we tried many times. We Googled even more, and we followed a really modern TDD approach with paper and pencil. And finally, we were able to extract a bit per minute and some numbers corresponding to the loudness of the selected file. It's
Right.
Sean?
No, I mean,
So, how does the game work? So basically, to make it work on a phone and on a browser, everything is based off the window size. Everything is scaled based on a ratio, and then the user clicks play, a map generator takes your beats per minute and creates obstacles, and basically fires them at you, it's very loud, fires them at you at the speed of the beats per minute. So, during each animation frame, it applies a velocity to an object, moves it along, checks whether a user's interacting with anything, and checks whether they're alive or dead. At the end of the game, if you're not dead, end screen comes up, and you get more points.
Cool. All right, so for management, so for the first week, we practically abandoned all the semblance of proper workflow management, which is not good. Don't do that, all right? Because the project first is a bit experimental first. So, however, we did do retros, sporadic stand-ups, and 2-day sprints, but did not generally stick to a good agile approach in general due to the experimental way we were working on. So we accomplished a lot during the first week. We had a functioning minimum viable product before Friday. However, we recognized that we could be a bit more efficient. So in the second week, we reverted to something approaching to agile approach.
Yeah, we actually found that this approach worked pretty well. It enabled us to just go a bit fast and loose in the first week so we could experiment and learn all these new concepts. So it worked pretty well. Week 2, we definitely found that, well, we basically recognized that we needed to use proper workflow management. Because we had a product now, we had to be able to apportion out work on bug fixes and features and things like that to individual teams, 2s and 3. So it worked pretty well.
And to obtain feedbacks, we share the game with friends and family, and we outsource our user and marketing research to a third independent party. As you can see, 73% of the interviewed prefer Dino Run over other popular games. And our prediction for the user count, for the player base, is around 90,000 by the end of July. And remember, I mean, after all, we are the past, the present, and the future of the gaming industry. So thanks a lot for listening, and please go on playing and try to beat Sean's scores. They're way too high.
Let's give a huge round of applause for all of the groups. They did amazing work and great presentations today.